So here I'm just going to run through some general factoring stuff so you can figure out what you know, what you don't know, because you think you know something and then 2 weeks pass and you're like, what am I doing? So the purpose of this is to help remind you of all the different techniques that you might use for factoring. So if you want to work these out right now on your own and then come back and watch the video and see how we do it, that would probably be the best idea. So we'll pretend that you did that, and now I'll go on to actually solving these problems. So whenever you're looking to factor this, remember when people are saying factor, they don't mean multiply it all out again, okay? This one is actually partially factored for you already. What you want to recognize is you have 8 times something minus x times something. So again, we have x times something, 8 times something minus x times something. So I'm going to factor that out. It would be 8 minus x times that something. And that's really all there is to factoring that particular problem. Got it? Okay, now for the next one. This one, the first thing that you should do looking at this problem is say, well, these guys both have something in common. What they have in common is a 5 and an x squared. So if I pull those out, who's left? Out of the first term, I have an x squared left, and out of the second term, I have a 4 left. So at this point, you have to decide, am I done factoring, or is there more work to do? Of course there's more work to do. You should recognize this as the difference of squares. And hopefully, recognizing that, you'd say, okay, this is x squared, and this is 2 squared. Now, I happen to remember that that means that there's going to be something that looks like this, and it's going to be x plus 2 and x minus 2. Okay. Now for this one, this is something where you're going to use factoring by grouping. So a good way to get started is to come in here and say, all right, I'm going to group them. Now it's important to remember we can only do this because this is a plus sign. If this had been a minus 4x, we would have wanted to rewrite it as plus negative 4x and then grouped it like that. Okay, so you never group around a minus sign. You always group around a plus sign. Now for each one of these, we can see what factor they have in common. This first group has a y in common, x plus 3. The second group has a 4 in common. If I factor out a 4, I'm left with, again, an x plus 3. So this is similar to problem 1. Again, I have y times something plus 4 times something. Again, y times something plus 4 times something. So that means when I factor it out, it's going to be y plus 4 times that something, like that. For problem 4, this is more of your standard quadratic or trinomial, standard quadratic equation that we will look at, where we have something squared times 5 something in the middle. So we might be more tempted to solve this problem if it looked like this, or be able to recognize it a little bit better. But the pattern's the same. You have x squared, x. Remember here, this is x squared, squared, and then x squared in the middle. So you still have the pattern of something squared times that something in the middle. Okay? So we're going to look, and we're going to say, okay, well, there's basically the 2 ways that I can get that 2x that I'm going to be concerned with are 2x squared and x squared. 7 I can get from a 1 or a 7. Because this is negative, that means I have to use a plus and a minus. So whenever I'm factoring these out, 1 has to be a plus, 1 has to be a minus. Now I'm going to guess as to where the 2x squareds go. So we'll pretend that one's there and that one's there. And then I'm going to throw in a 1 and a 7. And by design, if I FOIL this, the first and the last terms will already be working, right? First is going to give me 2x to the 4th, which is what it needs to be here. The last will give me minus 7, which is what it needs to be here. So what I really have to focus on are the inner and the outer terms. So outer gives me negative 14x squared, and inner gives me plus x squared, which is totally wrong, because that's this, which is not that. So that's bad. And so I have to figure out where I'm going to go from here. So since the number was completely wrong, I'm going to switch my numbers. So instead of 1 and 7, I'm going to do 7 and 1. Minus 2x squared plus 7x squared. That gives me 5x squared. So I have the right number, but I have the wrong sign. So since I have the wrong sign, the way to get around this is to flip my sign. So instead of a plus and a minus, I'm going to go with a minus and a plus. And now theoretically, this should work. Outer, inner, and that indeed gives me minus 5x squared, which is exactly what I wanted. So that one was a little bit longer to solve. Now for this one, this is straight up the sum of two different cubes. It's just important to notice which cubes that they are. The first cube is 2a squared cubed. Because if 2 is cubed, you get 8. If the a squared is cubed, you get 8 to the 6th. Plus y cubed. So we set up our template, and we say, okay, since this is a plus, that means that's a plus and that's a minus. The guy on the end is always a plus, and then we have two square terms. And again, if you're like, what are you talking about? There's actually entire videos talking about how to do this. So if you're just completely lost, it's, well, because you maybe didn't watch them. So you should go do that. It'll be good for you. So the terms that are going to go into here are 2a squared and y. 2a squared, again, remembering that that whole term is going to get squared, and then y. And then 2a squared, and then y. I'm going to go ahead and multiply these, not multiply them out, but simplify it a little bit. So 2a squared squared, remember that the exponent applies to each term inside the parentheses. So that's going to give me 4a to the 4th minus 2a squared y plus y squared. For this one, we'll see if there's anything interesting. Let's see, what can I factor out? I think I can factor out a 2 for sure. Let's see if I can factor anything better. So if I factor in a 4. I can factor out a 4. Perfect. Okay, so I'm going to do that first. If I pull out a 4, I'm going to have 8x cubed minus 125 y cubed. And if I stare at this long enough, hopefully I will see that I've actually got a difference between two cubes. It's just making sure you figure out what goes in there. Here's going to be 2x, and here's going to be 5y. So 2 cubed is 8, x cubed is x cubed, 5 cubed is 125, and y cubed is y cubed. So I'm going to set up my template. Since this is a minus, that means that this has to be a minus and this has to be a plus. The last term is always plus and the first and last terms are squared. So I've got 2x and 5y, 2x in parentheses, and 5y, 2x and 5y. So now I just have to make it pretty. Like that. And I'm good to go. All kinds of fun. Now we're going to go with this problem, which is actually pretty ridiculous looking, actually. If, the first thing we'd like to do is to go ahead and try to reduce this, well, because we're trying to factor it. If it helps, something you can do is go ahead and pull the x out first. So then we end up with 12x squared minus 84x plus 147. And you might be like, well, that doesn't really help me a whole lot. No, it doesn't. Okay, so I got to kind of look at these and you're like, okay, so this is divisible by 2. This is divisible by 2. This is not. Now, it's possible I'm just going to have to unfoil it from here, but I'm afraid. So I'm going to try to do something else first. I'm going to avoid that at all costs. So I can't divide everything by 2. Let's see if I can divide by 3. Well, I know I can divide 12 by 3. Now, there's actually this trick that if the digits of a number add up to a number divisible by 3, then that number itself is divisible by 3. So 8 plus 4 is 12, which is divisible by 3. And 1 plus 4 plus 7 is also 12, which is divisible by 3. And actually, I can go off to the side and I can confirm that those are both divisible by 3. And again, the way you find these things out is just by, experiment and just getting good at it. You can just kind of see it. But that little adding up the numbers together to get them to add up is a pretty cute little trick. So 49 and 27. So I can pull a 3 out of all these now. So I've got 3x, so 12 divided by 12 divided by 3 is 4. 84 divided by 3 I've already found is 28. And then 147 is going to be 49, like that. Now, again, this is not necessarily an easy one to see. It's just something that happens over time. You might notice that this is 2x quantity squared, and you have over here is a 7 times 7 is 49. So that's something that's definitely valuable to recognize, is that I've got those. And what I like about that is if I combine those numbers, 2 and 7, I get 14. 14 plus 14 is going to give me that 28. So that's going to be the difference of 2 squares looks like right there. But let's go ahead and write it out to be sure. But we've got that same pattern that we're looking for. So 2x minus 7 times 2x minus 7. So that's my guess. And I can go off and I can confirm it. So I've got 4x squared minus 14x, and then minus 14x, this supposed to be an x, minus 14x, and then plus 49, and that's going to give me that 14x squared minus 28 plus 49. So I know I did that right. So now I can just rewrite that as 3x times 2x minus 7 quantity squared, and then we're done.